In this lesson, we're going to continue to practice solving equations that have quadratic techniques, and we're going to see what that quadratic techniques kind of means in this lesson. So if you look at number 1, you'll notice that we have a cubic equation, but the one thing I hope that you notice is that it has 4 terms, and whenever we've solved with 4 terms, we've used a specific method, which is factor by grouping. So I'm going to continue with that method, and I'm going to group my first 2 terms and my last 2 terms. In my first group, I take out the greatest common factor, which in this case is x squared. So I'm dividing each term by x squared, which would give me x minus 3. I'm going to bring my plus sign down, and then I look for a greatest common factor in my second group, which would be 7. And I have x minus 3, and we equal 0. So then my last step in factor by grouping is I wanted these to be the same, these factors in parentheses. That tells me I did it right, and then I pull each of these into their own factor. So I would have x squared plus 7 times x minus 3. From here, I'm going to take each factor, set it equal to 0, and solve. So I minus 7 from both sides. I have x squared equals a negative 7. I square root both of these, so I have x equals plus or minus. Don't forget that when you square both sides of an equation, you need plus or minus. And then 7 doesn't actually break down, but I can't leave that negative under the square root, so I'm going to write plus or minus I root 7. And there are, how many answers am I supposed to have for this problem? 3, right? My degree is 3. So there's 2 of my answers right there, positive I root 7 and negative I root 7. And this one here is a little bit quicker to do. I get x equals 3. So my 3 solutions are plus or minus I root 7 and 3. Let's see if I put a graph on here. I did not. If you want to graph this, you can punch this in your calculator and you'll see that it crosses at 3, and you wouldn't see it crossing anywhere else because those 2 roots are imaginary. Number 2, I'm going to let you guys try, and then you can come back and see how you did. So hit pause and try this one. Hopefully with 2, you underline both, so your GCF is x squared. And then the one thing that can kind of trip you up here is this negative. So I see that my greatest common factor would be negative 4. So when I divide both those by negative 4, I do end up with x minus 3, because a positive 12 divided by negative 4 would be negative 3. So I have x squared minus 4 times x minus 3. I'm going to go ahead and skip a step here, see how you do with that. I switch sides right away. So if you wanted, this is here I added 3, and then here I'd add 4. That's where those 2 equations came from. So when I square root of 4 again, I need my plus or minus is 2. So plus or minus 2, and x equals 3. So this graph would cross the x-axis in 3 spots at negative 2, 2, and 3. So you could graph that in your calculator too if you wanted to. Number 3 now, this is the ones that they look really kind of crazy, I think, because you have rational exponents, but they're actually not that bad. So here's where the idea of a quadratic technique comes in. In order for us to factor something, I want you to think of if this problem was written like this. This would be a pretty easy problem for us to factor. These are ones we like because they're really quick and easy. The rule for us to be able to factor something using quadratic techniques, I'm going to put the exponent on this x of a 1. As long as this middle term's degree is half of the highest degree, you can factor it using your quadratic rules. So you have to have that number be half. So if you times it by 2 or divide it by 2, you're going to get that other exponent. So 2 times a half would be 1. 2 times a half is 1. So it is half of it. That's what works for quadratic equations, and so we're going to apply that to different rational exponents. So for example, number 3 here, the only way I know I can do this using quadratic techniques is if 1/3 is half of 2/3. Hopefully you realize that it is. So when I go ahead and try to factor this, I'm going to do my 2 parentheses, and I'm looking for factors of x to the 2/3, which sounds crazy, kind of, right? But what that actually is x to the 1/3 times x to the 1/3. So think about that for a second. If I gave you this problem on the side, that wouldn't be a problem to do, right? We know we have the same base, so we would add the exponents. They multiply to make x to the 2/3. So really, you can kind of see where that comes from then when I'm looking for factors of that. Then after I get that first part, it's pretty easy. I am still looking for factors of 5 when added together make negative 6. So hopefully you realize that would be minus 5 and minus 1. And from here, I still set my factors equal to 0 and I solve. Before I do that, I just want to point out that remember x to the 1/3 is the same as the cubed root of x. So if you would ever see this problem written in radical form, this is the original problem we were just given is in rational form. It also could be written like this and it'd be the same problem. So you might want to write or by this original problem. It could be the cubed root of x squared minus 6 times the cubed root of x plus 5 equals 0. So it can be given to you in rational or radical form. And I don't care which way you work out of. So if you want to change your rational to radical or your radical to rational, whichever way you prefer, you're going to get the same answer either way. So you can go ahead and switch them if you like. So for this problem, when I set each factor equal to 0 and solve, so I have x to the 1/3 minus 5 equals 0, x to the 1/3 minus 1 equals 0. So x to the 1/3 equals 5, x to the 1/3 equals 1. Here's the part that might be kind of confusing on how you're going to get rid of that 1/3. So there's a couple ways to look at it. I could think of what number can I times, or what can I do to both of these to make this number turn into a 1, because that's really what I want. So hopefully you see that you could cube it, because power of a power, I'd have x to the 3/3, which makes it x to the first. And that's my goal, is to get x by itself, not x to the 1/3. So I can cube both sides, and I end up with x equaling 125. So that's 5 times 5 times 5. Another way you could have looked at it is if you decide to write it in radical form, it would have been the cubed root of x equals 5. So then hopefully you realize when you are cube rooting, to undo that you would cube both sides. So the same answer. So I have x equaling 125. There's one of my answers. And then over here, same idea. I'm going to go ahead and cube both sides. 1 cubed happens to be 1. So x equals 1. If you would check this solution using your calculator, both of them would check. Now, some people have asked, one of the common questions is, you always know how many answers you're supposed to get based on the degree of your problem. How am I going to get 2/3 answers? So that doesn't really work. When I'm doing quadratic techniques, I'm expecting to get the same number of answers as a quadratic, 2. That's not going to always hold true, but most of the time it does. So we can't say that's a steadfast rule that works every single time, but for the most part, it kind of does. So we can kind of think of that. I just don't want you to think that it's if you get one answer or not as many as your degree, you think you're wrong. Sometimes that still does happen. So for this, I get 2 answers, and I'm good. Number 4 then, I have x to the first, I might want to put that 1 in there, minus 3x to the 1/2 minus 10 equals 0. So I first check to see if I can use my quadratic techniques. Is half of 1? It is, right? So when I make my 2 parentheses, I'm looking for factors of x to the first. Well, hopefully you see that that'd be x to the 1/2 times x to the 1/2. Again, if you do it over here, x to the 1/2 times x to the 1/2, same base, we add those exponents, so it does multiply to make x to the first. And then I'm looking for factors of -10 when added together make -3. That would be -5 and a +2. So now as I set each factor equal to 0, and solve, I get x to the 1/2 equaling 5 and x to the 1/2 equaling -2. In order for me to get x by itself, I would square both sides on both of these. So I have x equals 25, x equals 4. Now, what can actually happen here, because I have an even index, this problem can be also written like this: x minus 3 root x minus 10 equals 0. And so sometimes I can have some answers that don't actually check. And here's how you know that's going to happen. In my last problem, that wasn't going to happen because I had cubes, And I can take the cubed root of positive and negative numbers and they're still real answers. There's no imaginary roots with a cubed root. Here, in this problem, I have a square root. So right here, in my steps, I could have written this as the square root of x equals 5, the square root of x equals a negative 2. And if you remember from a previous chapter, whenever we saw that we had the square root of x equaling a negative, something wouldn't work out for us. So let me just kind of highlight that here for you. Right here, I have the square root of x equaling a negative. That's not going to check when I plug this in. And so anytime you see that you have a square root or a fourth root or a sixth root equaling a negative, that answer is not going to check. So this is my one that doesn't work, and this is my one that does. What's kind of cool about this one is I expected to get one answer because my degree is 1, and I did get one answer. So that it makes you think that you're on the right track. That's not always going to hold true though, so you can't look at that as a final rule. If you did want to, let me just show you something here quick. Let me show you this check just to prove to you that this 4 doesn't work. So I'm going to use this problem because I think this is easier to substitute out of. I would say 4, I'm replacing the x's with a 4, minus 3 times the square root of 4 minus 10 equals 0. So the square root of 4 is 2, so I have 3 times 2. 3 times 2 is 6. So 4 minus 6 minus 10 is a negative 12. Which definitely does not equal 0. So this proves that this answer does not check. If you plug the 25 in, the 25 will check. So you can go ahead and try it and see that, but that one's going to work. So you always can either notice what I highlighted here, that the square root of x equals negative 2, or plug it into your original problem and you'll be able to tell. Number 5 looks different than number 4, but it's actually the same problem. So I could write this as x minus 6x to the 1/2. Equaling 7. So I can do it the same way I did number 4. First thing though, we always have to, when we're going to factor an equation, is get our equation equal to 0. So I'm going to minus 7 from both sides. And if you want to leave it in radical form, that's fine. If you want to write it like this in rational form, you go ahead and do that. I'm going to try to factor. And my factors of x to the first. You might wonder if that half rule applies, but remember right here, in a rational form, you can see that. So instead of writing x to the half and x to the half, I'm actually going to write the square root of x, since I'm choosing to write this in radical form. I'm looking for factors of negative 7 when added together make negative 6. So negative 7, positive 1. Those are my two factors. So now as I set equal to 0 and solve, I'd have the square root of x minus 7 equals 0. The square root of x plus 1 equals 0. I add 7 to both sides. I subtract 1 from both sides. Hopefully at this step, so before you square is where you want to check to see if you have any that aren't going to work. Here I have the square root of something equaling a negative. I don't even have to go any further. I know that one's not going to check. On my left side I have a positive, so now I can square both sides and get x equals 49. So again, this problem gave me just one answer. Number 6, a couple more and we'll be done. Number 6 looks just the same, right? So why are we doing it? Let's go ahead and double check that it works. We have an x and a root x, so we know that that's half. So we'll make our 2 parentheses. I would have root x and root x again. Factors of 9 when added together make 6, 3 and 3. So here's an example of a double root we're going to get, right? So I have the square root of x plus 3 equals 0, and same thing, square root of x plus 3 equals 0. So when I minus 3 from both sides, I get the square root of x equaling a negative 3. Right here, they're both square root of x equaling a negative. So neither one of these is going to check, so we're going to say there's no solution. Maybe there's a solution we don't know how to find, but for right now in our math knowledge, we can't find a solution to this problem. So we're going to say no solution by factoring. Last one we're going to do is a little bit different. We have an x cubed minus 9x to the 3 halves plus 8. So I check to see if I have my half rule. Is half of 3 halves? It is. So when I make my two parentheses, I'm going to say x to the 3 halves, x to the 3 halves. Factors of 8 when added together make negative 9 would be -8, and -1. So I'm going to set each factor equal to 0 and solve. When I add 8 to both sides, I get x to the 3 halves equals 8. Then I add 1 to both sides, I get x to the 3 halves equals 1. So how am I going to get rid of this? There's a couple ways you could do it, so I'm going to show you both and let you pick. One way, from the form I'm in now, is to multiply by the reciprocal here, 2/3. Or I shouldn't say multiply. Take this term to the 2/3 power. Because when I take 3 halves times 2/3, I get x to the first, which is my goal. So I'd have to also take this 8 to the 2/3 power. How I solve that is I could punch this in my calculator and I'll get an answer, but I probably would put it in radical form. So I would rewrite this as the cubed root of 8 squared. And you can choose here what you want to do first, if you want to square it first or take the cubed root. I personally take the cubed root first so I can do it in my head and I have smaller numbers. So the cubed root of 8 is 2, and 2 squared, because I just did the cubed root, so that 3 is gone, but this 2 is still there. 2 squared is 4. So one of my answers is 4. Over here, I would do the same thing. Take it to the 2/3 power. So I have x equals, and I know anything that's getting done to a 1 is still going to be a 1. If you really want to write it, you could say the cubed root of 1 squared. Cubed root of 1 is 1, 1 squared is 1. So I get 1 and 4. The other way you could have done this is when I get to this point where it says x to the 3 halves equals 8. I'm just going to show you one of them. You can go straight into radical form here. And then in order for me to solve this, first I have the square root of something equaling 8, so I'm going to square both sides. So I would end up with x cubed equals 64. And then to get rid of that x cubed, I'm going to cube root both sides. What is the cubed root of 64? 4. So either way I did it, I got the same answer. And you can choose which way you like better and try those.